Here we have the first one. A positively charged insulated metal sphere is brought closed to an uncharged insulated metal sphere. Insulated metal positively charged. So this one contains a positive charge. This one. And the second one is uncharged, means uh, it was initially having equal distribution of positive and negative distributed uniformly, but once the positively charged sphere is brought close to the other one, the negative charges would be attracted by it and the positive charges would be pushed away by the positive charges. So negative would come forward and the positive ones would go at the back. So it should be the option B. Two charged spheres are suspended close to each other, which diagram shows distribution of charge distribution on the sphere and the direction. Okay, so we don't know what kind of charge is there on the two spheres, so it simply means we have to pick the most suitable option. So positive, the first one says positive attracting the positive, does not make any sense. Okay, the second one says positive so it says negative here and negative over here, and this one again okay, we'll consider this one also. So this is a strong candidate, at least as of now. The third one is the attractive charge. The force is attractive. All right. And the fourth one is the force is repulsive. So we can eliminate now the option D, because if the first one has positive, the second one has negative charge, the force should have been attractive. Now let's take a look at the option C. Option C is fair enough in a way that the force is attractive, but the only problem is if the force is attractive and the first sphere is positively charged and the second sphere is positively charged, the sphere should be having the charges right in front of each other because of attraction. So although the first one should be having positive, but the positive one should have been the positive and negative one should have been right in front of each other. So it should have looked something like this. If they are attracting each other. So that leaves us with the option B. In the option B, both the spheres are positive, hence they are sitting far away from each other. Question number 3, probably the easiest one. Which list contains only electrical insulators? Glass, plastic, rubber. It does. Glass, rubber, steel, no. Steel, no. Steel, no. So C, third one, A is the right answer. Now let's take a look at the option of question 4. A student rubs a rod held in his hand. Which action causes the rod to gain a large electrostatic charge? So if it is he is rubbing the rod in his hand, it means he is charging by the method of friction. So the method of friction works when both the objects are insulators. So we need to pick up the option then have both the objects insulator. Get out of here, steel magnet in the trash can. So we are left with option D, rubbing a polythene rod with a woolen duster. Yeah, you can just assume that it is a wall. A negatively charged balloon. Okay, so this is a balloon and the balloon is negatively charged. Which statement explain what happens? The negative charges on the balloon attracts negative charges in the wall, not in a million year. The same charges they never attract. Negative charges on the balloon will have no effect on the charges on the wall. It does have. The negative charge on the balloon repel the negative charges in the wall. Okay, we'll consider this one. Negative charges on the balloon repel the positive charge. No. So negative charge on the balloon should repel the negative charge in the wall. So the like charges should be repelled, unlike charges should be attracted. So if I draw the charge distribution, it could look something like this. Make sense? You see the wall is still neutral, the balloon is still charged, but the balloon containing negatively charged has attracted the positive on the near side and the negative is pushed at the back. Question number 6. A positively charged metal sphere is placed midway between two previously uncharged metal rods. Okay, positively charged metal sphere is placed midway between two previously uncharged metal rods. Okay. One of which is connected to the earth. Which diagram shows the charges on the rod? Alright, okay. So first one, not today. We're not going to fall for the first one because it says the like charges are being attracted. No, that doesn't happen. Then we have a positively charged rod which is placed. Okay, C looks like a good option. I'm going to skip C for a moment. That could be a strong candidate. There could be something wrong with the option C as well, but I'm going to explain it afterwards. Likewise, B is also a good option, strong candidate. Let's take a look at the option D. Can be eliminated straight away. Because like on one side, it's attracting the like charge. On the other side, it's attracting the unlike charge. So this is diplomatic behavior. We simply skip the last one. So now we need to choose between the option B and C. Let me tell you one thing. If there were no earth wire or there was no connection to the earth, C would have been the right answer. With no earthing. Because if there is one of the side is earth, it means the other side which is connected to the earth should be neutralized. So that leaves us with the option B. So cloth becomes positively charged, which means the rod is now negatively charged, which then means electrons from the cloth were loosely bound and they flow from the cloth to the rod, hence the cloth has become positively charged. Positive charges are transferred. Positive charges are transferred. No. We never discuss the movement or the transfer or the motion of the positive charges. So that leaves us with the very first option. Negative charges are transferred from the cloth to the polythene rod. Now the polythene rod to which the electrons are now transferred becomes negatively charged, and the piece of cloth, since the electrons leave the cloth, so it'll be left with positive charge. For 7, it should have been the right answer. Question number next. The diagram shows an uncharged ball coated with a metallic paint. Okay. The ball is suspended from an insulated thread. It is placed near a positively charged rod. Alright, fair enough. So maybe if I just zoom in the diagram to extend the sphere only. Yeah, so the sphere looks something like this. And then we have a rod which looks something like this. So the rod has positive charge, and the uncharged ball, we have uncharged ball with metallic paint, so it should contain both positive and negative. So the question is technically about the distribution of the charges. Any guess? D is the right answer, absolutely. So negative will be attracted and the positive would be pushed all the way to the back. A polythene rod becomes charged when rubbed with a dry woolen cloth. The charge caused is a result of magnetism? No way. Friction producing movement of protons or electrons? Electrons. Movement and protons in this chapter can never be in the same sentence. Okay. A positively charged rod is brought near to the end of an isolated uncharged conducting sphere. Okay. What are the sides x and y? Okay. So x would be having negative and y would be having positive. So that leaves us with the option, which one? X negative and y positive. What do you say? Are slightly better. They're slightly more advanced. A positively charged rod is held close to an earth metal sphere. Okay. What describes the charge on the metal sphere? So what describes the charge on the metal sphere? Okay. So the charge on the metal sphere, first of all, if this is positive, this side would be negative and this side would be positive. And since the rod is kept there, the rod is still there. So the side which is connected to the earth would be neutralized in such a way that electrons from the ground will enter the sphere and they'll neutralize the left side. So what is this charge left on the rod? First of all, negative. Neutral and neutral eliminated, and it is negative because electrons are attracted towards the rod. As you can see over here, electrons are attracted towards the rod. It is positive because protons are repelled by the rod. No, charge is not positive. Matter of fact, the positive charge was dissipated as the electrons from the earth were able to move to the ground, move to the sphere. Okay, let's take a look at the next one. I'll skip this one for a while. This is related to the topic current electricity. Once again, a slightly better one. The ones with the earth wire are always slightly better. A metal sphere is connected to the earth. A positive charge rod approaches a sphere and stops before touching it. So the negative would stay here, positive would be pushed away. Now this side, the other side would be neutralized. This side would be neutralized by the motion of electrons from the earth to the sphere. So first of all, the final charge on the sphere. Well, whether you like it or not, but the final charge is negative. So option C, option D eliminated. Sorry. Yeah, option C and option D eliminated because it says positive charge moves, eliminated. Final charge on the sphere. If there were no earth wire, then it would have been neutral. But now since there is earth wire, so the other side, which contains the like charge with respect to the rod, is neutralized. So that leaves us with the option A. Negative charge moves from the earth to the sphere. That makes sense also. Okay, question number 14. If the charge is like, then it should be on the extreme sides. If the charge is unlike, then it should be at the close ends, in front of each other, and they should be attracting each other. Should be able to answer in 5 seconds. 1, 2, 3. B is absolutely the right answer. Question number 15. A positively charged rod is held close but not touching an isolated metal sphere which is not earthed. There is no earth wire with the sphere. So the sphere would still be neutral. So the question is technically about the distribution of charge. We can get rid of option A. We can get rid of option B. So that leaves us with the option D. Because the rod is positive, so the opposite charge would be distributed at the close end, and like charges would be distributed at the far side. A small uncharged metal sphere hangs from an insulated thread. A negatively charged rod moves closer to the sphere. Moves close to the sphere, okay. Wait, what? Metal sphere is initially uncharged. So it'll be having both positive and negative. D says there is no effect on the conductor. Even a charged rod is there at the front. Eliminated straight away. C and B also eliminated because C and B say that the metal sphere has somehow become positive or negatively charged, but it's not. It was initially neutral and the sphere has not touched anything. There is no earth wire. So how come the neutral sphere become either positively or negatively charged? That cannot happen. So that leaves us with the option A, and that makes sense also because if the rod is negative and we have a sphere here which is being hung by a thread, then the like side would have positive, the far side would have negative, which is identical to the diagram A. And then it also say that the string will be pulled towards a rod. So now it would look something like this. Let's take a look at the this one was done already. 17, I think D was the answer, question number 17, because X will have negative and the other side Y will have positive. Yeah, 18 also done. This one, which diagram shows magnetic field? It's okay, magnetic field not done yet. A polythene rod is rubbed with a duster. The duster attracts piece of paper. The duster attracts piece of paper. Okay. Polythene rod is rubbed with a duster. Okay. If a polythene rod is rubbed with duster and both are insulators, so we are executing the method of friction. So both of them should be charged. And the proof is the duster attracts the small pieces of paper. So it should be A straight away. Matter of fact, from the very first statement, we get the hint that we are doing the process of friction, charging by the method of friction. And it turns out that by the method of friction, the two objects have been charged as well. How do we know? The proof is duster attracts the small pieces of paper. So if one of the object is charged, the other one is also having the opposite and equal charge. So let's say the duster, we don't know, but let's just assume the duster is positively charged. So if the duster is positively charged, then by the method of friction, the polythene rod must be negatively charged. So if the overall charge on the duster is +6, the overall relative charge on the polythene rod should be -6.